My lovely students, today we are going to discuss about the second part of the alternating current. In this second part of the alternating current, we will discuss what is the relation between the induced EMF and the currents for the circuit having the resistor, having an inductor, having a capacitor separately, or it is the combination of the LR, RC, LC and the RLC. But as per our the syllabus, we have to first going to discuss about the circuit having the resistor only, inductor only and capacitor only. So, what is a circuit? The first question. A circuit is a path which have the different components. When the components are taken only in the single way, that means either having the resistor or having the inductor or having the capacitor, each and every one to be the oppose, and suppose the inductor will oppose, that will known as the inductive reactance. When the capacitor will oppose the flow of the current, then that is the capacitive reactance. But if a circuit having the combination of R with the L or R with the C, L with the C or RLC in series or the parallel, then the effective resistance offered by that circuit is known as the impedance. That things we will discuss at the latter part of this one. So, now we are going to find what is the relation that will exhibit having a circuit only the resistors. So, let us now recapitulate you for its the previous part which will take the vital role in calculating this one. Means in this chapter we have to going to discuss about the circuit having the resistor, inductor, capacitor, LCR and the wattless currents. But if we will go to find the relation having with the E and the I, E means the EMF, I means the current of a circuit having the resistors. So, when we will take a circuit, it will provided with the some EMF or the potential, you will say suppose that EMF is equals to E0 sin omega t, that E is equals to E0 sin omega t we defined in our the previous class. Similarly, by taking that one, if it will flow through the circuit having the resistor, what is the value of the I? This is the one part. Then we have to discuss, suppose instead of the resistor the inductor is there, the same EMF we are supplying E0 sin omega t, how the I to be the calculated, and that I and the E at any interval of the time, how they to be the related, they to be the given the graphically with its the phasor relation and with its the phase relationship with the waveform. Similarly, the circuit having the capacitance. So, my dear students, you now come with your the copy and the pen and paper and keep the atmosphere clean and give the attention towards the each and every steps which I am providing to you. You go through it and you will easily remember how you have to calculate the relationship between them. So, let my students, let us now first come to find the circuit theory. We have to discuss about the circuit theory. So, the first case is circuit having resistor only. So, which circuit we are discussing here? The alternating circuit we are discussing here. Suppose this is the resistor, that is connected with an alternating source. This is the symbol of the alternating source. This is the resistor. This is the resistor R. This is the alternating source with the E is equals to E0 sin omega t. What is our aim? To find the relation between E and I. relation between E and I of a circuit having here the resistor only. This is the resistor, this is your the alternating source. So, if E is equals to E0 sin omega t, if this is your the theta or omega t, this can be your the E only we have taken. So, if E is equals to E0 sin omega t, our relation is between E and your the I. So, if E given, we have to find out our the I. So, we know V is equals to your the IR, implies I is equals to your the V by R. V is equals to your the E, so that is equals to your the E by your the R. So, this E is equals to E0 sin omega t by your the R. E is equals to E0 sin omega t, it is provided. E is equals to E0 sin omega t by your the R. So, when some current to be your the flowing through your the conductor, it will give you or oppose, that is it is the resistance, and with this resistance how this E and your the I to be your the related, that we have to calculate. I is equals to the this much, E0 is your the peak value, as we said that E is equals to E0 sin omega t, where E0 is equals to so E0 is equals to BAW, that is equals to we can say ba. So, E is equals to E0 sin omega t means E is equals to ba sin omega t, means BA omega sin omega t. So, this BA omega, that is the peak value, which is a constant one. So, this is the peak value constant, R is the resistance is the constant. So, E0 by R, again it is a constant. So, that is equals to your the I0 sin omega t. So, if a circuit is provided with your the resistor, then if E is equals to E0 sin omega t, then I is equals to your the I0 sin omega t. So, now the question is how this E and the I to be your the related. So, if E is equals to E0 sin omega t, now we have to plot I is equals to I0 sin omega t. So, when we will plot I is equals to I0 sin omega t, this is its the peak value, this is its the peak value. So, this is its the peak value it will provide. So, this is the peak value of your the E, this is the peak value of your the I. So, this I is equals to your the I0, this E is equals to your the E0, this is the graph for E is equals to E0 sin omega t, and this is the graph for I is equals to I0 sin omega t. So, what is this omega t? This is your I is equals to your the E is equals to E0 sin omega t, this I is equals to I0 sin omega t. So, if this omega t is the theta, this omega t is also the theta, means which through which angle the E is indicated, at the same time the I also indicated with your the same angle. So, this omega t means the angle of suspension of angle of inclination for your the E and for your the I at that time interval is remain same. Just you observe here, this is for your the 0, though we have taken it is the theta, means this is equals to your the pi by 4, this is equals to pi by 2, this is equals to your the pi, this is equals to your the 3 pi by 2, this is equals to your the 2 pi. Means at theta is equals to 0, where the E, there is your the I. When the theta is equals to pi by 2, where is your the E, means on the which line it is the E, on the same line it exists your the I. Means this E and the I, here the E and the I, here E and the I are on your the same phase, means along your the same direction they are showing. But what about their magnitude? Here E have its the maximum value of here the E0, here I has the maximum value of the I0. Between E0 and here the I0, which one is the greater? As we know, here I is equals to here the V by R, means that is equals to here the E by R. E is equals to E0 sin omega t, means this is E0 by R, that is equals to the I0. So, I0 is equals to E0 by R, but E0 divided with the R, that gives you the I0. Therefore, E0 is at the greater value. You see, the E0 have its the greater magnitude and I0 has its the lesser magnitude at that time interval. If they two be are the plotted, suppose this is your the I, though we have taken the red as your the I and the black is your the E0. So, this is your the E0 and this is equals to your the I0, means this is for the E, this is for your the I. Both are your the inclining the angle of the theta, that is equals to your the omega t. So, with here the same angle, on the which line your the E is there, on the same line the I is there, but the E is always ahead and I is its the behind on the same line with its the magnitude. So, if you go for your the screen, as per your the screen, you are observing that at the bottom to the right you see the E0 and the I0 on your the same lines, and they are inclining with your the same angle of your the theta, or that is your the omega t. So, what type of the conclusion you will find here? Note, circuit having resistor, the phase means generally you remember the angle, the phase of E and I are same, means they are on your the same direction, the phase of the E and the I to be are the same. Suppose I is equals to your the I0 sin 45 degree, it being given, and for the I0, if we will take the value of the 30, then the question, what is the value of here the E0 in the approximately. So, if I is equals to I0 of this one, means for this case the circuit having your the resistor. So, if I is equals to this one, then E is equals to how much according to the formula? E0 of the sin 45 degree must be, because it is your the resistor, means both have your the same angle. So, if I is equals to 30 sin 45, then E is equals to some value of the sin 45 only. Then the question comes, if it is the 30, then what is the value of this E0? So, means if this is the I0, then what will be the E0? You see, the E0 is always greater than of your the I0. If the I0 stands for your the 30, then what is the value of the E0? It must be the greater than of your the 30. Means it can be, never it will have your the single answer. It can be more than 30 of a sin 45. That is your the value of your the E. Similarly, if the E is given, what is the value of the I? Suppose again, if E is equals to your the 20 sin 54 degree, then I will be the how much? The circuit having the resistor. Then if E is given, I must be of your the some value of your the sin 54 degree. But here it is the E0, here we have to write for the I0. Out of the E0 and the I0, E0 is of the greater value, this greater value is of the 20, means from this to this the amplitude here according to our question, that is the 20. Then what is the value for your the I0? I0 must be less than of 20. So, this value must be your the less than of the 20, means either it is the 10 sin 54 degree or the 18 sin 54 degree or the 7 sin 54 degree likewise. So, this is your the circuit having your the resistor only. So, what conclusion we will obtain now? If a circuit having your the resistor, the phase of your the E and the I are your the same. This is for your the first way of the consideration. For the second way of the consideration, we will switch over for your the circuit having your the inductor. Circuit having inductor. So, if a circuit having the inductor, there we have to find the relation between your the E and your the I. This is your the inductor connected with the alternating source. This is the alternating source. This is the inductor. So, here E is equals to your the E0 sin omega t given. So, when the current to be the flow through it, through this inductor, there will be the some resistance, and what is the value of that resistance we will calculate. Okay. Let us now start. What is the relation that will exhibit of a circuit having here the inductor, where we have to find the relation between here the E and I. If E is equals to this much, L is your the inductance of this coil. If some alternating current is passing through it, I is passing through it, then we have to find out what will be its the current. So, according to your the inductor, by using your the Faraday's law, you know that E is equals to L of a di by your the dt. Are you know this formula? Because we know E is equals to d phi by your the dt, that is equals to d by dt of your the phi. Phi is equals to your the Li. So, the question will come, sir, why you have written phi is equals to Li, not you have written phi is equals to your the Mi? The M stands for your the mutual case and the L stands for the self case. Though a single coil being your the taken, that will give you the self inductance. So, this phi is equals to your the Li. So, this is equals to L, that is the coefficient of the self inductance, that is the constant comes out, and that is equals to your the di by your the dt. So, E is equals to L of di by dt. This expression you know from your the Faraday's law, that expression we know. Therefore, if E is equals to that one, we are interested to find for the expression of your the I. So, we know E is equals to L of di by dt. We are interested for your the I, means E by L is equals to di by dt, implies di is equals to E by L of dt. Just rearrangement. E by L, this dt came here. So, E dt by L, E dt by L is equals to your the di. Di is equals to E by L dt. So, if you will integrate that one, so integrating di of E by L dt. So, this di integration will be the I, this E is equals to E0 sin omega t by L of dt with its the integration is equals to E0 by L integration of sin omega t dt, and this is equals to, so from which one? From your the 0 to t. So, this is equals to E0 by your the L of your the sin omega t will be your the minus cos omega t, and if no integration limit is there, then it is only from the integration of this one of minus cos omega t. So, that is equals to minus E0 minus cos omega t by your the omega. Sin omega t integration will be the cos omega t by omega, and sin integration will be the minus. So, minus cos omega t by your the omega. This omega comes out, this minus also comes out, then this is equals to your the cos omega t. You see this I is equals to your the this much. But we know that if the induced EMF is equals to E0 sin omega t, the current which it will provide, that is also on the same form, I is equals to your the I0 sin omega t. It should be in this form, but now it is coming in the form of your the cos omega t. When we are going to compare, when the two things are the compare and they are basic things to be or the remain to be or the same. So, here though E is a function of the sine, we will try to express the cos in terms of your the sine. So, if the cos to be expressed in terms of the sine, that is equals to E0 by omega L or L omega, cos omega t will be your the sin 90 minus omega t. Sin 90 minus theta is equals to cos theta. So, cos omega t is equals to sin 90 minus omega t. So, this is equals to E0 by omega L sin of omega t minus pi by 2. E0 by omega L sin of omega t minus of the pi by 2. So, this is equals to E0 by XL sin omega t minus pi by 2, that is equals to I, implies I is equals to I0 sin omega t minus pi by 2. So, here there is a confusion. Sir, there is a minus sign, but you have omitted that minus sign. You see, when there is a minus sign, here it is the sin 90 minus theta. When inside the 90 minus theta I will taken minus as the common, then this will becomes here in the form of sin minus of some angle. So, sin minus of the angle means if you will write sin of minus theta, that is equals to minus sin theta. Therefore, sin of this one with the minus, minus means this minus becomes here the plus and this plus will becomes here the minus. You see 90 minus omega t, when the minus will taken common, minus becomes the plus, plus becomes here the minus. So, it is in the form of the sine. Therefore, though I is equals to I0 this one and E is equals to E0 of this one, if we will compare these two, so what type of the conclusion we will find here? You see E is equals to E0 sin omega t, I is equals to the I0 sin omega t minus pi by 2. Here sine with the angle of here the omega t, here the sine of the angle of omega t minus pi by 2. So, what I said about the phase? Phase is the relation between their the angles. Here the E angle, if it is the theta, here the I angle is of here the theta minus pi by 2, means it is always lags behind. So, if we plot the phasor diagram likewise, this is your the wave diagram, we will say wave diagram. If we plot the wave diagram, this is the wave diagram, this is the phasor diagram, we will find. So, first you will take E is equals to the E0, any type of the either this or that, E is equals to E0 sin omega t. We know E0 and I0, out of them which one is the greater, which one? E0 is always at the greater side, E0 is always at the greater side. Though this is for the E is equals to E0 sin omega t, this magnitude portion is your the E0, and here we have taken E and here the I, both are. So, here also first we have taken here the E, then we will plot for here the I. So, if for the I we will plot, suppose this is your the theta or that is the omega t. So, when omega t is your the 0, Here omega t is 0, sin 0 is equals to 0, E 0 is equals to 0. But if we will plot for the I omega t is the 0, then this is the sin minus 90. Sin minus 90 is equals to here the minus 1. So I is equals to here the minus I 0. So at here the theta to be here the 0, the I will go for here the minus. So therefore the I will come here. So sir, why you have taken here, you have not gone below? It can be at the bottom portion also, because I have not. You just look, this value is the E0. This E0 value is always greater than of the I0. So what magnitude we have taken for the E0? For the I0, you see this is the magnitude of the E0 in the negative side, but for the I0 that must be the less. Therefore, if this is equals to this much, on the bottom side that must be less than that one. Therefore, I have taken this. So from here it will go there, and for it will have the maximum, again it will come here, again it will go there, likewise it will be continue. So this one will correspond I is equals to I0 sin omega t minus pi by 2. That means E of the phase omega t, but I of the phase omega t minus pi by 2, it is 90 degree behind. Similarly, if we will plot for it the phasor diagram, like of here the resistance, suppose this we have taken is equals to here the E0, E. Means though we have taken that is the E, this is for the E we have taken. E is equals to E0 sin omega t. If this angle is of here the omega t, then what will happen for here the I? I is equals to I0 sin omega t minus pi by 2. Means from the angle omega t, it will minus pi by 2. Means it will go behind. So if this is equals to the I, then from this to from omega to this is equals to the 90 degree, or this is equals to the pi by 2. Means from E to I will be the 90 degree behind, means this one is of here the 90 degree. If this is the E, this is your the I. This is the phasor diagram. So in this diagram, one here we have taken along the y-axis is the I, and the another one this is for your the I. So along the y-axis E and the I, and this is your the theta is equals to omega t. So what is the conclusion? The phase of here the I is 90 degree behind that of the E. Otherwise, the phase of the E is 90 degree ahead that of here the I. Question will come in the two different way. So according to the question, you have to give your the answer. As we came to know that when a circuit having here the inductor and some current is flowing through it, with the provision that E is equals to E0 sin omega t, I is equals to here the I0 sin omega t minus pi by 2, that shows that the phase of here the I is 90 degree behind that of here the E, or in the reverse way, the phase of the E is 90 degree ahead that of the phase of here the I. So on that I is equals to here the I0 sin omega t, on that I is equals to here the I0 sin omega t, I is equals to here the I0 sin omega t minus pi by 2. This I0 was your the E0 by your the XL, and this XL we have taken as the omega L. So why this I is equals to the I0 sin omega t means this E is your the potential, this XL must corresponding for your the resistance. Therefore, I is equals to the I0 sin omega t minus pi by 2. This XL, it is a resistance. Resistance due to inductance. This is the resistance due to inductance or inductive reactance. and that one is nothing but this XL is equals to your the omega L. Omega is equals to your the 2 pi n L of the L. This n here I have taken for the frequency. In some books you have this n as your the f. So either 2 pi fl or 2 pi nl. Therefore, this omega L means this is your the XL is directly related with your the n, or that is directly related with your the f. Means if the frequency will increase, then this XL will increase. If the frequency will decrease, this XL will the decrease. So, for your the AC in our Bharat, the frequency is generally taken here the 50 to 55. But for your the DC, the frequency is equals to your the 0, because DC is your the unidirection. There is no frequency for that one. Therefore, DC is equals to 0. So, if the frequency is equals to your the 0, means if this n becomes your the 0, this XL becomes your the 0. XL becomes 0 means the resistance becomes the 0. So, when the resistance will becomes 0 means the entering component to be your the more value. So, which one is entering through your the inductor? The current is entering through your the inductor. So, if some DC to be your the pass through your the inductor, then it's the resistance will your the reduce, for which the DC can pass through your the easily. These things you remember, it will come in your the examinations like your the entrances. For your the DC, what will be your the frequency? The DC frequency is the 0. Or for your the DC, which component to be your the protected, either AC or the DC, either AC to be your the allowed through your the inductor, or DC to be your the allowed through the inductor. According to this expression or according to this idea, you have to give your the answer. And for your the DC, the resistance is your the 0, therefore the flowing portion will be your the more, means the DC can pass through your the inductor, but the AC will never pass through your the inductor. But for your the AC, what will happen? It has its the frequency. When it has its the frequency means its resistance will your the increase. When the resistance will the increase, the passing of your the input AC to be your the reduced there. So, this is your the XL, and if you plot a graphical representation of that one, suppose you will take your the XL here and your the frequency here, then the graphical portion will be your the straight line, because as the frequency will increase, n or your the f, likewise your the inductance to be your the increase. So, this is the graphical form. And what will happen for your the capacitance part, we will discuss now. So, let us now go to find the relation between your the E and the I of a circuit having your the capacitor. So, circuit having capacitor. Circuit will have your the capacitor. So, let us have a circuit. This is your the alternating source. This alternating source E is equals to E0 sin omega t. This is the capacitance of your the C. Suppose some current is flowing through it. So, this is your the capacitor symbol. If these two lines will be the one is the greater and one is the smaller, that will be your the battery. So, this is the capacitor, this is the E. So, if E is equals to E0 sin omega t, we have to find what is the value of your the I. So, we are interested to find the I. So, this I to be your the determined by using your the C. So, by using the C and your the E, we have to find the expression for your the I. So, we know C is equals to your the Q by V, means Q is equals to your the CV. We know Q is equals to your the CV. So, if it is Q is equals to your the CV, C is equals to C, V is what your the potential, this potential is equals to the E0 sin omega t. So, this is equals to E0 sin omega t. Q is equals to C E0 sin omega t. We are interested to find your the I. So, we know I is equals to dq by dt. Sir, why you are putting such formula? There are different formula. I is equals to the v by r, or I is equals to the q by t. So why you have taken dq by dt? Because you see the q is already provided for you. So dq by the dt, it provides for you the instantaneous. So I said repeatedly, that is the instantaneous. So at any instant, I is equals to the dq by the dt. We are interested for the I. So I is equals to d by dt of the q. What is the value of a q? Q is equals to c 0 sin omega t. C e 0 sin omega t. That is equals to c e 0 of d sin omega t by the dt. That is equals to c 0. If sin omega t to be the differentiated according to the chain rule, sin function is omega t, but it is with respect to t, differentiation will not be possible. So with the same function of the sin, we have to differentiate that one. So sin function is omega t, we differentiated with respect to omega t, but omega t was not there, though we have put there, we have to given another d omega t. So this is equals to c is 0, d derivative of sine of some function with respect to the same function according to the formula, that is the cos of the same function. So cos of omega t, d omega t by dt, omega comes out, dt by dt is equals to 1. So this is equals to c e 0 omega cos omega t. So if this is c 0 omega cos omega t, that can be written e 0 by 1 by c omega of cos omega t. That is equals to e 0 by 1 by c omega of sin omega t plus pi by 2. So this is equals to e 0 by something of sin omega t plus pi by 2, and this is equals to I 0 sin omega t plus pi by 2. Which one this is? That is for your the I. So I is equals to your the I 0 sin omega t plus pi by 2. If I is equals to I 0 sin omega t plus pi by 2, it being came from your the cos omega t. Here there is a question. Sir, cos, if it is your the sin omega t plus pi by 2, why not you have put cos omega t as sin pi by 2 90 minus theta? When you will take your the sin 90 minus theta, that is also equals to the cos theta. It came in the form of the sin, but the sin with your the omega t, it being started. I said earlier, when the comparison is to be made, there should be a similarity of its the basic one. Means if we make a comparison, a man can be compared with your the man, a torque can be compared with your torque, but a different things cannot be compared with your the another things. Means a man cannot be compared with your the elephant. We cannot compare to that one, because elephant is one category, man is the one category. Though this is E is equals to sin omega t, means with the sin omega t is in the positive side, therefore we have to take an sin in that way, omega t must be in its the positive side. Therefore instead of taking sin omega 90 minus omega t, which is your the cos omega t, but sin 90 plus omega t, that is also your the sin omega t. So here for the cos omega t, we taken sin omega t plus pi by 2, but we never taken sin 90 minus omega t. Though I is equals to your the this one, so what is your the xc? Xc is equals to your the 1 by c omega. So this 1 by c omega we have taken as the xc. Sir, why this is taken as the xc? You see, though it is came in the form of the sin, it is nothing but for your the I. When the I is flowing through this one, we know that the I is always something of a sin something. Means I is equals to I0 sine omega t plus phi minus phi, whatever it may be, I is equals to I0 of sine something. You see, this is the I, already came here the sine, then the remaining part will be here the I0. So, I is nothing but that is equals to here the E by here the something. We know I is equals to here the E by R. So, this is the E. The numerator part must be here the E. You see, the numerator part is satisfying for here the E0. So, the denominator part that must be for your the resistance. So, in the denominator we have that is the 1 by c omega. So, this 1 by c omega, for our the simplification we have taken as the xc. So, this xc is equals to your the 1 by c omega, and this xc is known as your the resistance. You see, E by something, that is the resistance. So, this 1 by c omega is the resistance. So, this xc is the 1 by c omega is your the resistance due to conductor or conductive reactance. This is your the conductive reactance. So, this X is your the conductive reactance 1 by c omega. For your the inductor, we know XL is equals to your the omega L. This XL is known as your the resistance due to inductor or inductive reactance. This is your the capacitive reactance. And this c omega, that can also be written as 1 by omega is equals to 2 pi n with your the c. Means if the frequency to be your the increase, the xc to be your the decrease. So, if we plot a graph by taking your the frequency with your the xc, the graph will be the likewise. Means as the frequency will your the increase, the xc value will your the gradually decrease. So, this is its the graphical form. Now, we will go for its the wave diagram and for its the phasor diagram. Wave diagram and phasor diagram. E is equals to E0 sin omega t, but I is equals to your the I0 sin omega t minus pi by 2 of the plus pi by 2, omega t plus of the pi by 2. So, when this is the plus of the pi by 2, you will plot the graph. Suppose this one we have taken for E is equals to E0 sin omega t. This is your the omega t. This we have taken as your the E1. So, when omega t is your the 0, E is equals to your the 0 because sin 0 is the 0. When this is your the 90, sin 90 is the 1, E is equals to your the E0, means from this to this, that is equals to the E0. At the same time, if we go for your the I, when omega t is the 0, sin of 0 plus 90, 0 plus 90 is equals to the sin 90, sin 90 is equals to the 1. So, this I is equals to I0, means at the omega t that is equals to 0, that is your the I0. But we know that out of E0 and the I0, E0 at the greater side and the I0 at the lesser side. Therefore, it will start from here the I0. So, from less value of the E0 we have to take in, either here, whatever, but not above to that one. So, from this to this, then it will come, then it will go, then it will go, and it will come. So, this one will be the I is equals to I0 sin omega t plus pi by 2. So, here the sin of omega t, here sin of omega t plus pi by 2. Therefore, the phase of I is pi by 2 ahead that phase of E. So, if we plot the phasor diagram, that means for your the phase diagram you will take, and this is equals to your the E, which is at the angle of omega t, the from this to this means this is your the pi by 2, that is for your the I. Therefore, we come to conclusion that if a circuit having the capacitor, then the phase of the I is pi by 2 ahead. If the circuit having the inductor, the phase of the I is the 90 degree behind that of the E. This is the comparison between your the capacitor and your the inductor. My dear students, now we analyze about an alternating circuit when having a capacitor. If some EMF to be provided, then the current which is passing through it is ahead of your the 90 degree to that one. But if a circuit having your the inductor, it is 90 degree behind that of your the E. So, by taking these concepts, now we will go to discuss some of the problems or the numericals regarding to this one. So, let us now remember and you go through your the note what type of the expressions we have derived for the circuit having your the inductor and your the capacitor. Suppose your question number 1. A inductor is provided with here the alternating source of E is equals to suppose 10 sin 10 t plus 30, and this is your the inductor of your the 2 Henry C. The question is find the current equation versus time and the value of I RMS S. This is a question. So, this is the inductor as we have drawn the diagram. E is equals to the 10 sin omega t plus 30. The question is find the current equation. So, current equation means we have to find I is equals to I0 of your the something. That current equation we have to find. So, if this current equation you have to determine, and the second one is the find it say the IRMS, and your the IRMS to be your the determine. So, kindly go through the question what being given, what is your the asking. So, when the IRMS is there, you generally know that IRMS is equals to I0 by your the root 2. So, generally you will put this I0 is equals to this one by your the root 2, and that will give you the wrong answer. Here the question is find the current equation, the circuit having your the inductor. So, when the circuit having the inductor, what is the current equation? As we discussed, I is equals to I0 sin omega t minus pi by 2. That is the equation that we know. So, here the I is equals to I0 sin omega t minus pi by 2. So, we have to find here the value of here the I0. So, what is your the I0 we have taken? I0 is equals to E0 by your the XL. That is the value of the I0. Go through your the problem. So, if this is E0 by XL, here E is equals to 10 sin of this one. So, what will your the E0 value? So, E0 value is equals to 10 by your the XL. What is the XL? XL is equals to your the omega L. So, omega means your the frequency. So, what is the frequency you see here? That frequency is equals to your the 10. Sir, how you came to know that the frequency is equals to 10? Because I said if E is equals to E0 of sine, that is equals to omega t plus phi in this form. So, here the omega is equals to your the 10. So, this omega means E0 is equals to your the 10, and the omega is also equals to your the 10. So, this is equals to 10 by 10 into L. L is equals to inductance. What is the inductance given here? The 2. So, into 2. that is equals to your the 10 by your the 20, that is equals to your the 0.5. 0.5 of the I0 means this is equals to your the ampere. So it becomes your the I0 value as your the 0.5. Therefore, this is equals to 0.5 by your the root 2, that is equals to your the IRMS. This is equals to your the second part is over. But the first part is find the current equation. For your the circuit having your the inductor, the current equation is I is equals to I0 sin omega t minus pi by 2. So this is equals to I0 sin omega t was what? When the alternating source have your the sin omega t. When the alternating source have your the sin omega t, then I is equals to omega t minus pi by 2. But here the question, the alternating source have your the sin omega t plus phi 4. Therefore, this omega t here will be 10t plus 30. This will be the 10t plus 30. Then minus of the pi means that is equals to the 90. So this is equals to 10t minus 60. So I is equals to I0. What is the value of I0? I0 is equals to the 0.5. So 0.5 of sin 10t minus 60, that is equals to the I. Are you clear to my point? So the question is find the current equation. Current equation I is equals to the this much versus of the time, that is your the time, because the time is not specified here. The second one is the find the value of the IRMS. IRMS is equals to I0 by root 2, but the I0 value you never put, that is equals to 10 here, because this is the form of the E means this is the E0, not this is your the I0. So that I0 we came to know E0 by XL. So that value we put and we find the IRMS. Are you clear to my point? Let us now go for your the second question. Question 2. Find inductive reactance when the frequency of 50 Hertz is passing through a coil of 10 Henry. Passing through a coil of the 10 Henry. This is the question number 2. Then we will go for the solution. So find the inductive reactance when the frequency of the 50 Hertz. I said when the problem to be solved, there will be the 5 steps. This is the question. You go through and understand its meaning. What are the given data you have to write? First, the frequency is the 50 Hertz is given. So frequency is equals to n or f, whatever you are writing. So frequency is equals to the 50 Hertz is passing through a coil of the ethic Henry. So the coil of a Henry means that is your the inductance. So inductance that is equals to L is equals to your the 10 Henry. So what is asking? Inductive reactance. So inductive reactance is equals to your the XL, that to be your the calculated. You see this Hertz and Henry, they are in your the MK system, means the given data are in the MK system. So there is no necessity to convert from one to your the another. Then your the put the formula, get the answer. For your the inductive reactance formula XL. So what is your the XL? XL is equals to your the 2 pi NL, that is the formula. Here n is the frequency is given. So 2 into pi is equals to 22 by 7 or 3.14, whatever you will write. So 2 pi n is equals to your the 50 into L is equals to your the 10. So, when you will simplify this one, that will give you the XL, but what will be the unit of that one? When the value to be determined, you never forget to write its the unit. If the unit will not be mentioned by you, the 100% mark you will not receive, only the 0.5 will be deducted for that one. This XL is nothing but that is your the resistance, though we have taken in the M case, what value you will obtain, that of your the ohm. Similarly, instead of the finding the inductive reactance, if the capacitance will be there, then there will be the no coil, it will be of your the capacitor, the Henry to be there expressed by your the some capacitor value microfarad. So, 2 mu f and this 50 hertz, then the inductive capacitance will be the capacitive reactance. So, if the capacitive reactance is XL, that is the 2 pi n 1 by 2 pi nc, that is the formula, this is the xc. So, this pi n is given, the c is given, you can calculate. So, this is how to solve here the problems. So, with this we concluded the relation having your the circuit with the inductor, capacitor and your the resistors. So, in your the councils you will get the questions regarding this one. Please go through what I have said and you make it the notes, and if you go thoroughly you can answer each and every type of the questions. Okay, thank you very much to my students.